Digital transformation plays an important role in the era of Industrial Revolution 5.0 to all sectors of life, especially business and manufacturing. As the demand for automation grows exponentially, control systems must be easy to program, flexible, reliable, and cost-effective. Here, we provide an overview of the implementation of PLC system in effort to automate MSME-based production process. So, let's get acquainted with one of the MSMEs in Samarinda. PT Osada Nusantara, established in 2020, is an MSME engaged in the processing of herbal drinks based in Samarinda City, East Kalimantan. Osada Nusantara sells packaged herbal products such as artisan tea, coffee, as well as original forest honey and cultivated honey, which have many health benefits. For 5 years of operation, Osada Nusantara still relies on conventional production methods. This has an impact on the production process that is less than optimal in meeting market demand and obstacles to expanding product expansion. This is certainly a challenge for Osada to improve the effectiveness and efficiency of its production process. In this video, we will analyze and provide ideas for production process engineering based on automation systems as a form of digital transformation implementation to be adopted by Osada so that long-term business goals can be achieved. A process control system, or PCS, consists of a set of electronic devices and equipment capable of handling stability, accuracy, and eliminating dangerous state transition in the production process. Meanwhile, a PLC, or Programmable Logic Control, is a specialized computing device used to control and automate industrial process. The main function of a PLC is to monitor inputs from various sensors, process the data according to pre-programmed logic, and control outputs to actuators or other devices like PCS. These capabilities allow PLCs to manage complex automation tasks with precision and adaptability. PLCs connected to computers are able to integrate all the tools in the production process into one control center. So the application of this method is certainly able to reduce time, energy, cost, and even be able to increase safety and health guarantees for humans because it can reduce human intervention in the tools.
Here I will explain how to implement an information system in the tea production process. Previously, Osada still used manual method for their tea production process. We thought it will take too long to dry the tea for 7 days, so we suggest the use of tools and system in this drying process. We suggest to use a tool called batch rotary dryer. This tool will be programmed use PLC-based PCS. First, the things to do is to organize all the tools in the production process and input our work instruction according to desired production standard. After that, we enter the instruction according to the process need into the PLC. Later, all information on the production machine will be integrated in the PLC, which will then be processed by the PCS system so that the result information can be displayed on a PC or computer console.
Now, I will explain the engineering application of management information system in the honey production process flow using a PLC based of PCS system. The first process is the preparation of raw materials and then entering the production house for the checking process. This process is a process to determine whether the honey produced is in accordance with the quality standard set by BPOM. In the checking process, this is where the application of the management information system is applied through a tool called refractometer that functions to measure the water content and other content in honey. Before the implementation of MES, Osada had to check the composition of honey manually by looking at and testing it, then confirming it whether the honey has fermented or not in 4 to 7 days. However, with the use of refractometer, Osada can monitor it directly through a computer that has been integrated with the PCS system through PLC. The refractometer used must be integrated with the PCS system. We can connect it using RS-232C connection to transfer data so that it can be integrated with the PLC. After that, Osada only needs to monitor through the computer with the estimated time given to determine that the honey is finished and ready to enter the bottling stage and then marketed.